In this video, we are going to determine increasing and decreasing intervals of a function. So in this first example, we are being given a graph and asked to determine the open intervals on which the function is increasing and decreasing. So increasing really just refers to where is the function going up from left to right. So as I look at this particular graph, I'll notice that this part of the graph is going up. And when we give the interval, we give it in terms of our x values. So you'll notice that the increasing starts at an x value of -2, and it increases until the x value is at 1. So we would say it increases from -2 to +1. And we do not include those endpoints. We don't put the square brackets to say it touches them, because that's where it's changing. It's either going from decreasing to increasing or changing from increasing to decreasing. So in the second part, we're looking at or asked to decide where it's decreasing. So you'll notice this is the part of the function here that is decreasing, and it had an arrow there. So what that says is that the x values start at -infinity, and they decrease until we reach this x value of -2. And of course, that was where it switched to where it was then increasing. And then we also have another interval where it starts again at the x equal 1. And notice it is decreasing. That arrow says it just keeps going to the right. So we started at +1, and the x's go to the right all the way to infinity. With this next example, we are not given a graph, but we're still asked to decide where it is increasing and decreasing. So the first thing that you're going to want to do, if you're not looking at the graph, is you're going to want to take the first derivative. And so when I take the first derivative of this function, I am going to pull the 2 to the front. 2 times 2 is 4, x to the first, plus pull the 1 to the front. 1 times 12 is 12. And then just 12, x to the 0, which we know is just 1. And so then if you'll set your first derivative equal to 0, that is going to give us what we call critical values. And so if 4x plus 12 is equal to 0, subtract 12 on both sides, 4x is going to equal -12, divide both sides by 4, and x is -3. So that is, if I'm going to have it where it changes from increasing to decreasing, it will occur at -3. But we have to test that, and I'm going to do that here at the bottom. And this kind of also leads into the next section where they're asking you to do this type of test. So you're going to pick points that are both to the left and right of your critical values, and you're going to plug them into your first derivative. So for example, I could choose the point where x is equal to -4, and when I plug it into my first derivative, the f prime of -4 would be 4 times -4 plus 12. And so in that case, I would get a -16 plus 12, which would equal a -4. And I'm not so much interested in what the value is as much as I'm interested in the fact that it is negative. And because it is negative, that would tell me that the graph is actually decreasing on that interval. So I would know it's a decreasing graph on that interval. Okay, so then if I plug in a value that's bigger than -3, probably the easiest thing to plug in would be an x value of 0. So f prime of 0 would be 4 times 0 plus 12 would be equal to +12. And again, it's not so much the value as much as the fact that it's positive, because if it's positive on that region, then that tells me the graph is actually increasing. So now when I go to write my intervals, I see this particular graph increases from an x value of -3 to +infinity, and it decreases from -infinity to the x value of -3.